I'll clean up the whiteboard a bit. This switched mode power supply is a bit more complex, so there are some things we still need to analyze. Let's clean up our whiteboard and leave it free so we can understand some parameters. Excellent. What is the circuit that opens and closes this gate? This circuit is composed of some more components. Sometimes, one of those components is an extra winding inside the same transformer that delivers 15 volts to power this switch. Sometimes, it directly takes the 310 volts through a resistor. You will find all of those components surrounding the transformer and the switch. But what regulates this? Because there is something that is regulated here, it is not only opening and closing. What is regulated here is what we know as PWM. Pulse width modulation. What does this mean? You will remember that we had a constant alternating current here, which is given by the voltage of 50 to 60 Hz. But in this case we pass to 0, and then we pass to an alternating voltage, but already created by the switch. This speed is already given by the switch. It is fixed, but what we will vary is the pulse width. What does this mean? To understand it, let's draw PWM now. Now we will draw pulses in this area. The idea is that each of these points is almost at the same distance. This means that each pulse is at the same distance and speed. But what I can do is vary the width. Let's see if I can draw it and it turns out well. We would get up to there. Each of these pulses starts exactly at the same distance of time from one another, but what I am varying is the width of the electrons entering on one side and the width of the electrons entering on the other. This can be done by a switched mode power supply, and what regulates is the width of the wave that goes up. The switched mode power supply knows that on the other side of a half-wave rectification and the wave below is lost, so if more power is needed, it makes the top wave wider. And if less power is needed, it makes the top wave narrower. So, through a notice that the switched mode power supply has at this point, through an element that is warning or communicating from this side to this, it is informing the switch if more or less electricity is being consumed. Then it tells him how wide he has to pulse, the speed of it. But what is going to vary is the pulse width, the width of the wave that goes up, that is the one that is used. If it is being used less at that moment, it delivers less. If it is used more, it delivers more. But it delivers what is used so that through the transformer, it does not get excited and the voltage is lost afterwards. This is something that a conventional power supply cannot do. There is no communication. We cannot vary the pulse width because the transformer works directly with 220 volts, 50 Hz, or 60. And this is the advantage of a switched mode power supply. Of course, this implies that there are many more components that can break. The PWM circuit is a bit of a complex circuit, but this is what we find ourselves with. We have to learn it and we have to understand it. So, how does this communication take place? That is the question that I will explain. This happens through an optocoupler, and we will talk about it in the next video.